So OpenAI just released this MLE-bench, evaluating machine learning agents on machine learning engineering. This may not seem like a big deal at first, but I think this might be looking at potentially the most important question in AI. We seem to be approaching a time when neural networks, these AI models, start contributing more and more to science, to innovation. They're also getting better and better at doing certain tasks, even better than humans. As Leopold Aschenbrenner put in his situational awareness paper, is that a common objection to transformative impacts of AGI is that it will be hard for AI to do everything. There will be areas where we need improvement in robotics. Automating biology, research and development might require lots of physical lab work and human experiments, etc. But those things aren't as important. I would state, in fact, that there's only one thing that we need to really be concerned with, and that is at what point will AI be better than humans at doing AI research? Aschenbrenner believes that just kind of extrapolating the development of AI capabilities over the next few years, he believes that AI would easily take us to or beyond the levels of the best humans by the end of 2027. You might have seen Geoffrey Hinton receive the Nobel Prize in Physics for his contributions to the development of neural nets. Demis Hassabis got an award for his work with AlphaFold, among other things, but his alpha AI models that contributed to various breakthroughs in chemistry. What happens when machine learning models are the best machine learning researchers? As he says here, AI research can be automated, and automating AI research is all it takes to kick off extraordinary feedback loops. And certainly that kind of intuitively makes sense, right? That would be recursive self-improvement. As it improves itself, it also gets better at improving itself, which of course kind of leads us to the intelligence explosion. And this is where things get a little bit weird, right? What happens when machine intelligence goes straight up? Now, of course, there's people that think this is complete nonsense. It's not going to happen. This is kind of a science fiction scenario. Some people think that it will happen, but we're still far away from it. Some people believe that this will happen soon and will be extremely, extremely dangerous, possibly the end of life as we know it. Some people, of course, are very positive, saying that when this happens, there will be more productivity and abundance and all the good things that we want. Me personally, I'm very optimistic about AI and kind of the benefits it will have for the human race, but I would be lying if I said that I'm not at least a little bit concerned about this line where automated AI research kicks in. We have no idea what an exponentially increasing artificial intelligence looks like. They say we can learn from history and history repeats itself. Not here. This is a whole new chapter, never before seen, a whole add-on pack, DLC, a whole sequel of brand new things. We have no clue. And that brings us back to OpenAI and the MLE-bench, where they take these agents, right? So these autonomous AI agents capable of planning and pursuing the tasks against sort of longer time horizons, of adjusting their approach, of planning and reasoning through certain tasks. And instead of unleashing them on researching and then buying the best running shoes for you on the internet, we unleash them on machine learning engineering. So this is Kaggle. Level up with the largest AI and machine learning community. There's a lot of stuff here. There's courses and competitions and forums. For developers, there's models and notebooks and data sets. For researchers, there's various advanced machine learning with pre-trained models, etc. A lot of great high-quality public data sets. But the thing that we're looking at here is the competitions. You may have heard about the Vesuvius Challenge. A long time ago, Mount Vesuvius erupts and bury a vast library inside a villa that contains a lot of papyrus scrolls. And while the residents of this villa would disagree with me, this was a very fortunate event because it preserved those papyrus scrolls so that we can see them all these years later. Obviously, it's horrible that it happened, but these scrolls generally decay and disappear. Here, there, they were preserved. And so this competition, for example, pays money to people that are able to use machine learning to scan and read these scrolls. This would not be possible without machine learning. Here, take a look at these. And people that are able to build these AI models, to use machine learning to kind of read and understand these scrolls, to detect the ink in those pages, etc., they get paid money. These are prizes awarded to the various teams and funded by various people. Looks like the Musk Foundation gave him $2 million. Looks like other people that donated are the founder of WordPress, the founder of Shopify, And it says here that this person is anonymous, but I think I know who that is. I recognize that face. It's Larry David. And there are many, many, many more competitions like this with prizes in the millions of dollars, including the ARC prize. So this is the ARC AGI benchmark or competition that you might have heard of. And those are the very competitions upon which OpenAI is unleashing their agents. And this probably should not come as a surprise. They do pretty well. They use both open source agents and frameworks, as well as OpenAI's very own agents and frameworks, including, of course, the O1 preview, the thing that was kind of created for this purpose, created to be able to reason and perform certain agentic tasks. So without further ado, the MLE-bench, published by OpenAI. So they begin, we introduce MLE-bench, a benchmark for measuring how well AI agents perform at machine learning engineering. So when we're talking about AI taking over AI research, like this is very, very early on. We're just beginning to apply certain benchmarks and certain metrics to see where are we at in that whole progress. So this certainly doesn't mean that AI is ready to take over AI research, but this is at least kind of giving us into a glimpse of where are we in that process? Are we close? Are we getting closer? And so they put together several competitions from Kaggle that test real-world machine learning engineering skills. So each machine learning researcher or expert has probably a set of these like discrete skills that he or she uses to do AI research or machine learning engineering, whatever you want to call that. And these are skills such as training models, right? So training them, for example, for that Vesuvius challenge to recognize the ink on those papyrus scrolls. So one skill might be to train a model to do a specific task. Another one might be preparing data sets. So having high quality data sets is very important, for example, for training models, right? And then running experiments, right? So for example, this paper that we're reading right now may in the future be done completely by AI. It selected a hypothesis, it created a bunch of models, it gathered its data set, right? It created the experiment, it ran it, it wrote up a paper about it, and then we read it, which now makes me wonder. I mean, they have a bunch of human people on here, so they have a bunch of author names. So I guess we're not there yet, which is good. I don't know if we're quite ready for that. But the point is, so these are the skills that machine learning engineers, researchers, these are the skills that they use to do the stuff that they do. So we're trying to figure out how well is AI able to do that. And so they establish human baselines for each of those competitions, right? These are publicly available leaderboards. And so there's kind of two things here that they're using. One is the actual AI model. So like GPT-4, for example, is the AI model or one of them. And then there's something that they call scaffolding. So it's basically kind of a automated developer workflow that walks the model through the various tasks that it has to do. And the goal is to find the best performing setup. So the combination of a model and the scaffolding that works the best at completing these competitions, these tasks. And spoiler alert, they find that OpenAI's O1 preview, right, this new model that is caused quite a stir because of how big of a jump it had in various tasks like in physics and math and a lot of things that require reasoning. And they paired with aid scaffolding. And they'll go into what that means exactly. What does aid scaffolding mean later in the paper? And so that sort of pairing, that setup achieves at least the level of a Kaggle bronze medal in 16.9% of the competition. So let's call it 17% of the competitions. It scores a bronze medal or above. Keep in mind that the people competing are probably not just some random people off the street. Here, for example, for the Vesuvius Challenge, these are the people that won the grand prize. So Yusuf is an Egyptian PhD student in Berlin. This kid-looking fella, he's a 21-year-old college student and SpaceX intern. And Julian, who is a Swiss robotics student at ETH Zurich. So if you recall that robot that it can have wheels and just like roll around, and then it'll stand upright and it can like pick up the boxes and like put them in bins and open various doors while still having wheel hands or whatever you want to call that. Yeah, I believe the team behind that is out of ETH Zurich. So when they're saying here that in 17% of the competitions it takes part in, it takes a bronze medal or better, you kind of can understand what the competition with the other people taking part, kind of like their caliber, their level. And so they're continuing, while there's tons of various benchmarks for coding and various other things to do with AI, few benchmarks holistically measure autonomous end-to-end ML engineering. Right, so this idea of recursive self-improvement, of AI doing AI research, not too many benchmarks are out there kind of trying to figure out, well, where are we in that process? So they came up with one, and they open sourced the benchmark code as well here. I'll leave this in the links in the description, and they're calling it the MLE-bench. And the goal here is to, get some challenges, to get some challenging tasks that are representative of machine learning in general, meaning that if AI is able to do this, it would sort of show that it's able to kind of, in general, move the field forward, and compare that to sort of human level performance. I know some people accuse me of hyping things up, but this to me is probably like the really big question about where AI is going. How quickly AI models, AI agents will be able to improve their abilities on stuff like this will have a massive impact on everything forevermore. It feels like, right? Doesn't it? Either good or bad. I think after the Sparks of AGI paper by Microsoft, I feel like this is the other really big, important paper that we've covered in this channel. And these competitions that they're taking part in, they're across a variety of domains like natural language processing, computer vision, and signal processing. And they mention a lot of the challenges that are active right now have real world value, right? So there's the open vaccine and the Vesuvius challenge. That's this one right here, where they're scanning it and trying to figure out where the ink is, and then trying to figure out like what it's saying. And there are tons of actual like prizes, right? So over almost 2 million, it looks like, in various prizes across these 75 competitions. There were recently an article about how OpenAI, it's not being profitable. It is losing money. They're trying to get more funding and stuff like that. So, maybe this is their idea of moonlighting, right? Let's see if we can get these lazy AI models to do some work, to bring some money in, teach them the value of hard work. See if you can snag us that $1 million prize. And here's that kind of like the big statement that I'm talking about. Again, these papers tend to not hype things up. They tend to kind of like, it's understated. It tries to be neutral language. But listen to this. AI agents that autonomously solve the types of challenges in our benchmarks could unlock a great acceleration in scientific progress. This is a very, very big deal. Right? Can I say that? That's not hype, right? So this is the, I guess this is the Google DeepMind team. So here's Demis. I'm guessing this person on his right is John M. Jumper, the person that they're splitting the Nobel Prize for Chemistry with. So if I'm understanding correctly, the Nobel Prize in Chemistry 2024. So you have these two people that work for Google DeepMind. Then you have David Baker for computational protein design. So he's separate. He's got his own thing, and there's some sort of a split between three of them of how that's getting like split. And so for these two, it's for the protein structure prediction. So AlphaFold, AlphaProteo, and all those models that deal with the proteins and drug discovery and the designer proteins, protein binding, all that stuff. Video on that coming very soon. Make sure you're subscribed. It's going to be a good one. In it, we'll also talk about this thing. This is a cybernetic organism living in tissue over a metal endoskeleton. But the thing that they decided to use for the tissue is, what? I'm not even ready to talk about it. That's going to be in an upcoming video. And it's pretty disturbing, but we'll talk about that later. Subscribe so you don't miss it. You don't want that thing angry at you. But so they continue here. So this prospect of unlocking a great acceleration in scientific progress with these automated AI research models, right? It's a prospect that is exciting, certainly, right? But also warrants a careful understanding of model progress in order to deploy advancements in a safe and controlled manner. There's one thing they include in here that I think every one of these papers should have, and that is pictures. So here's the agent, right? And so the MLE-bench is an offline Kaggle competition environment for AI agents, right? So each competition is going to have a description, data set, and the sort of the graded score, right? So the AI agent kind of gets all this description of the competition, the data set, right? It does the thinking, the doing, whatever it needs to do, submits the answer, the final submission as a CSV file, and then gives it to the grader. Submissions are graded locally and compared against real-world human attempts via the competition's leaderboard. So let's come back to this in just a second. Let's talk about what scaffolds are. So scaffolding is kind of like an automated workflow that helps to kind of like walk the model through it, right? So We're looking for the best scaffolding and the best model, and these scaffoldings are open source. And so they've used 3 open source scaffolds. So AID, that was the one that in combination with the O1 preview, that's the best performing one. Then we have a research agent, referred to as MLab, and Code Act Agent, referred to as Open Hands. And so as you can see here, AID does much better than the other two. So it's maybe twice as good as Open Hands and maybe 10x better than MLab. Notably, AID is purpose-built for Kaggle competitions. So it's kind of like custom made for that specific thing, whereas other scaffolds are general purpose. And we'll dive deeper into that in a second, but they continue here that the best performing agent we evaluated O1 preview with AID, right? The scaffold AID uses scaffolding purpose-built for Kaggle competitions and achieves a medal, I'm going to say just 17% of competitions on average. I'll round some of the numbers up where appropriate, and I'll link this PDF down below if you wanted to go and take a look and then see all the details. They find that performance significantly improves when agents are given multiple attempts per competition. So for example, the O1 previews it doubles, right? The score doubles. So 70% at, pass at 1, so 1 submission, to 34 for pass at 8, so 8 submissions. You give it 8 submissions and you take the best score, right? So in that situation, it looks like it doubles its ability. Interestingly, it scores 8.7 given 24 hours to attempt each competition, but scores 11.8% when given 100 hours. So here they talk about what they refer to as trajectories for various models and various scaffolding. So GPT-4o with AID is here on the right, and then the same model with Open Hands, and then the same model with MLab. So as you can see here, it kind of starts by thinking what it has to do, and then kind of continues step by step, opening up the files that it needs. Right here, it looks like step 35, an error occurred, right? So it tried to open this file as a text file. That didn't work. And this is kind of part of this sort of autonomous agents, right? They kind of they try to do their thing. They run into issues. They kind of read okay, there's an error. What do I have to do to fix that error, right? So they kind of regroup and try again. There's a trial and error approach. And on the AID framework, kind of notice this little diagram here. So notice there's kind of this branching little tree of decisions. We'll come back to what this means in a second. And keep in mind, this one was the best performing one that's built specifically for these Kaggle competitions. So here they're describing how each scaffolding works. So MLab and Open Hands are general purpose scaffolds that take action by calling tools. And AID is purpose-built to perform a tree search over solutions on Kaggle competitions. And these agents run autonomously for up to 24 hours in our experiments. And so next they talk about how medals are awarded for, winning these competitions or how well you place, right? So Kaggle awards bronze, silver, and gold medals to top competitors based on their performance relative to the leaderboard. So depending on how many teams take part, it kind of breaks it down by how many people take part. So generally gold looks like, let's say top 10%. And then, if you have a small number of teams, it's like silver is top 20%, bronze is top 40. It looks like they're saying the threshold increases by 1 for every additional 500 teams. So, for example, if competitions have under 250 teams that took place, in order to get the bronze medal, you have to be in the top 40% of the people, or to get, bronze or better, which is what the best performing model plus scaffolding, that's what they did. So meaning that they were landing in the top 40, 17% of the time. I think I'm saying that right. That, I gotta say, seems impressive. And so here they mention that only 2 humans have ever achieved medals on 75 different Kaggle competitions. We'll skip some of the stuff. So they have rules like agents are forbidden from viewing solutions online, which can be found on Kaggle or GitHub. There's various rule breaking detection, plagiarism detection. Again, I'll link this below if you want to read through it. But as you can see here, so they tested GPT-4o with MLab Open Hands. Since that wasn't the best scaffolding, they put more effort into doing the AID scaffolding. And they've tested that one with the O1 preview. So again, that's the latest and greatest sort of reasoning model out of OpenAI, the one that has the really high scores on math and physics and stuff like that. Then you have GPT-4o, you have Llama 3.1, 405 billion parameters, and then you have Claude 3.5 Sonnet. So the O1 preview made the submission 98% of the time. It was a valid submission 82% of the time. And that is far and away the best out of all the models, including GPT-4o. Looks like it placed above median 30% of the time. Interestingly, if you look at this, it got the gold medal 9.4% of the time. So gold means being in the top 10% of the competing teams. And again, just to kind of round those numbers a little bit to make it easier to kind of remember and grasp, I would almost think of this as like 10% of the time, it landed in the top 10% of all the submissions, getting the gold medal. That, I gotta say, that seems big. And notice all the other models are not very close. You have GPT-4o at 5% in terms of getting the gold medal. You have Claude 3.5 Sonnet at 4.4. And this is an interesting thing. So there's varying amounts of compute, which I was a bit confused about at first because I'm like, compute like for the models. But what they mean is like when you take part in these competitions, Kaggle provides a certain amount of compute, like if you need to train these models, or users can also use their own hardware to compete. So the experiment actually gave access to kind of their own hardware for these agents. Again, so you need some sort of your own hardware to run these experiments, right? So if you're human, you go there, you use your own whatever NVIDIA cards or whatever cloud service you want to use to train these models, to take part in the competitions. So this is kind of an interesting thing to think about because we're giving these AI models kind of like, here's some compute, here's some like resources, some hardware for you to utilize to train these AI models that you need to train up to complete the competition. It's very meta, I would say. And so they were trying to understand if the models would adapt their strategies depending on the hardware available to them. For example, training smaller models when only CPUs are available, and training, larger models when GPUs are available. So GPUs like NVIDIA chips, the graphic processing units. So if I give you a beast mode NVIDIA card versus a potato, like, are you going to change your strategy and how you go about this? Like, I hope so, right? So it seems like it performed similarly in all experiments, didn't really use the second GPU. And towards the end here, before the conclusion, they have their impact on AGI preparedness. We talk about it having numerous positive impacts, right? Accelerating scientific progress in healthcare, climate science, other domains. But of course, agents capable of performing open-ended machine learning research. And if they're at the level of improving their own training code, they could improve the capabilities of frontier models significantly faster than human researchers. Again, that's kind of that idea of potentially having that intelligence explosion. And they're saying if innovations are produced faster than our ability to understand their impacts, we risk developing models capable of catastrophic harm or misuse without the sort of parallel development of securing and aligning. So basically our ability to just destroy everything will rise much faster than our ability to figure out how to prevent that from happening. And again, as somebody that's positive about life in general and also kind of positive about AI outlook specifically, this is the one thing where I'm like, all right, let's just be really careful here because we haven't seen anything like this before. So we have no idea, like maybe there's some sort of a limit to intelligence or how quickly AI can improve itself or maybe not. And we don't really know what that means. I think the blog Wait But Why did a great job of kind of like illustrating this with their artificial intelligence revolution part 2. So if you think about intelligence as kind of like this staircase, so this is how the intelligence increases, but it's also kind of these like step functions, right? So an ant simply doesn't have the cognitive capacity. Like the smartest ant doesn't have just the ability to do, calculus or whatever, right? So there's sort of these like step functions where new abilities are unlocked. So not only are you getting kind of smarter, there's like a new level that gets unlocked, right? So what's one step beyond humans? What does that look like, right? And they have this great picture where it's like, well, here's the biological range of intelligence, right? So there's humans, there's monkey, right? You can barely see it, right? So the ant and the human, they're like right there. And then, if you keep going up this ladder, up these steps, like way over here is artificial superintelligence, right? Right. It's kind of weird to think about, like, what even is that? If biological brains evolve over millions of years, like we can't even understand what these steps are. Like we can't even like grasp what that means. What does this mean, right? Or maybe this is not how it works. Maybe there's some like limit to intelligence or something. Again, no clue. So I think I'll leave it there. I'll link the PDF down below if you want to check it out. I think we covered most of it, but there's a lot more in the, after the actual paper ends in the appendix or whatever, various charts and kind of, they show what the scaffolding looks like, kind of like what those prompts look like. So that's something that's of interest to you. Check it out. They also open source a lot of this code. So if you wanted to test out your own models or try running some of this stuff, all that's available. But before you go, just tell me what you think about this whole thing, that it gets, 17% of the time a bronze or better, or 10% of the time it gets a gold. The fact that it seems to be able to do, some of this stuff pretty well, certainly seems like it will be getting better and better at automating AI research. It sounds sort of a recursive self-improvement. What do you think about that? How does it make you feel? Or maybe you think that this is kind of just nonsense, that this is smoke and mirrors, or it will never be able to replace any part of machine learning experts that are doing this kind of research, that the idea of an intelligence explosion is just like science fiction, is bunk. Let me know. I'm curious to know what you think. With that said, thank you for watching. My name is Wes Roth, and I'll see you next time.